Hey everyone, welcome to our next video. Today we're going to be going over 4.2. Let me go ahead and go to our notes. Four point two is basic sine, cosine, and also tangent equations. So sine, cosine, and tangent equations. So whenever you're dealing with an equation, here's what we have to remember. We are looking for all of our whatever variable it is. So let's say all like x that satisfy the equation. The part that we're going to have to like think about here is that whenever we say, for instance, um, like a cosine graph or something like that, remember that because of coterminal, you can always find a new angle that could work in the equation. So we're going to have to deal with that a little bit. So it's really important, this word all here. And I think as we do an example, you'll kind of see what I'm talking about. So example 1, I'm just going to say solve for all values of, in this case, I'll just use x as my variable. So for part A, let's look at cosine x equals 1. So we're trying to find every single x value that we could plug in that would make cosine equal to 1. So if I go back to my unit circle, remember that cosine corresponds with the x point, x coordinate. So it's happening right here. So this is at 0 degrees. The issue is that it's also at 360 degrees. And then also, I could keep adding 360 to this and keep getting an angle that satisfies. So basically what we're saying is we can just keep wrapping around, stopping at the exact same place, and we can keep getting x values that work. So here's how we need to write our answer to explain this. We would say x is equal to 0 plus 360 degrees k. So you could actually condense this a little bit and just say x equals 360 degrees k. And so the 360k, what it should remind you of is coterminal. Because that's what the k is it's just an integer. It's basically saying how many times would you like to wrap around the circle. So if k is 1, then you wrapped around 1 time. If k is 82, then you wrapped around 82 times. But technically, there would still be an answer in that location. So that's why we have to write it this way. In radians, we would write our answer as 0 plus 2 pi k, which we can just write as 2 pi k. So be careful whenever you're typing in answers and stuff on the homework. They can be picky about degrees or radians. I don't usually mind. I'm okay with whatever you prefer, whatever makes more sense to you. So let's go ahead and do another one of these. Let's do cosine x equals -1. So again, I'm going to come over here and look at my unit circle. Let me go ahead and draw all the angles on here. So I got 0, 360, up here would be 90, over here 180, and down here 270. And so remember that cosine corresponds with the x coordinate. So that would be right here. So that's happening at 180 degrees. So what I'm saying is that x is equal to 180 degrees. But we have to remember that we can keep finding answers in the same location. So we'll say plus 360 degrees K. And then in radians, this would be pi plus 2 pi K. All right, let's do some more. Oh, I also want to mention this. You can technically use the inverse to do this as well. So if you want to use the inverse function, it would be x is equal to cosine inverse of -1. And so if you type that into your calculator, you'll get 180 degrees. The issue is it can't tell you about the whole plus 360K part of it. So you want to be careful about that. I think it's best to just kind of think through them. But sometimes if maybe this is not something that you're used to seeing, if it's kind of a weird number or something like that, it may be helpful to use the inverse. And I'll do an example like that. Let's look at another one. This one is cosine x equals 0. And so if I come over here, I'm looking at my unit circle. I'm going to look for the place that that cosine is equal to 0. So that happens up here. It also happens down here. So this one, it's actually happening in two places. So there's kind of two ways to think about this answer. One, you could write it this way. X equals 90 degrees plus 360 degrees K. And then also x equals 270 degrees plus 360 degrees K. However, there's a more condensed way to write this answer. So 90 and 270 are 180 degrees away from each other. So you can actually write this a little bit nicer and just say x equals 90 degrees plus 180 degrees K. Now, if you wrote it separate, like on a test or something, that's okay with me. It's not the best way to write the answer, but it's correct, so I don't mind. In radians, this would be pi over 2 plus pi k. And so when cosine is equal to 0, that's the only time that you're going to see plus 180k instead of like plus 360k. And it's just because it's becoming 0 at two places that happen to be 180 degrees apart. So if I start at 90, if I go 180, I get to 270. If I add 180 again, I get back up to the top. If I add 180 again, I get down to the bottom. So see how it's going back and forth by only adding 180? That's why we can do it here. So just something to keep in mind, especially while you're doing the homework. Let's do another cosine one, but now I'm going to do not one of the quadrantals. So let's do cosine x is equal to half. So now for this one, instead of using the unit circle like I was using before, I'm going to go ahead and use my table. I have sine, cosine, 30, 45, 60. Sine is 1 over 2, root 2 over 2, root 3 over 2. Cosine is the opposite. So remember, we're looking for the angle right now. So if I look at my table, cosine is equal to 1/2 at 60 degrees. So I know that one of my answers for this is going to be 60 degrees. However, we have to be careful here because if we think about the entire circle, there's actually two different places that cosine is equal to 1/2. So yes, it's equal to 1/2 in quadrant 1 if I plug in 60 degrees. So like cosine of 60 degrees, yes, is 1/2. So that definitely means that x equals 60 degrees is definitely an answer. So I'm going to go ahead and write that down. But there's another place that cosine is positive and can equal 1/2. So I want you to think about where cosine is positive. It's positive in quadrant 1, and then think about it. It's also positive in quadrant 4. So that means that there's also a quadrant 4 answer to this problem that has a reference of 60 degrees. So there's actually two different answers for this one. Both need to be included. So x equals 60 plus 360k, because remember that I can keep finding angles in the same location if I just keep wrapping around the circle. So if I keep going, and as long as I stop at that place, so if I add 360, I can find coterminal angles. And then for quadrant 4, that answer would be, so this is 0 or 360. 360 minus 60 would be 300. So my other answer for this is x equals 300, again, plus 360k. And those are my two answers. Now, a question that maybe I would have had is, how come for part C we had two answers, so then we wrote it as one and we just used 180? But then for part D, we had to write them separately. Like, why could we not use 180 again? It's because these two angles are not 180 degrees apart from each other. So cosine equal to 0 is like the exception. That's the only time you're going to use 180 instead of the 360. Any other time, you would have to just write the answers separately. Something else just like to keep in mind, kind of connecting things together, is the fact that cosine's period is also 2 pi k. So if we, like when we're adding this 360, like we're really adding the period. Like we're saying that these answers would repeat every increment of 360 or 2 pi. Now in radians, I do want to write this answer for you in that. So this would be pi over 3 plus 2 pi k. And then 300 would be, let's see, this would be 12 pi over, 6 pi over 3, denominator of 3 for 60 degrees. And so this would be 5 pi over 3 plus 2 pi k. So this would be the radians answer. Again, I do not mind if you do radians or degrees. Now I want to warn you a little bit about what you may find online. What you may find online is that people will say to do this. Change it to an inverse function and get that answer. If you type this in your calculator, you will get 60 degrees. But that's it, right? You have to remember to add 360, and then you're also not getting 300 out of it. So there is a general form that you can use If you want to remember it, I mean, that's completely up to you. I think it's better to just work through these with the information that we've learned thus far. However, whatever works for you is what works for you, you know? So let me write the general form for you. So the general solution for y equals cosine of x. So you would get x equals cosine inverse of y. That'll be one of the answers, and then you have to add 2 pi k to it. And then your other answer, you would do 2 pi minus that value. So basically what we're saying in relation to part D, we're saying, okay, if we do the inverse function, we get the 60. Then if we do 2 pi or 360 minus that first value, we get the second value. So that's what this is trying to say. And now the way I showed you at first is like, I think it just shows more like reasoning and you kind of think through it a little bit more. But technically you could use the general form if you'd like. And sometimes the general form may be helpful, for, like if we have a weird angle, so or like a weird y value in this case. So let me go ahead and do some more of these just for more practice. I do want to do a like more of a one where maybe you have to solve it a little bit. So let's see. Let's do 2 cosine x plus square root of 3 equals 0. So sometimes you may have to manipulate the equation a little bit. I do want to bring down my little table. That way I can keep it with us as we're doing these problems. So I can like refer back to it. So for this one, first I need to get cosine x alone. So I can subtract square root of 3 from both sides. That gives me 2 cosine x equals negative square root of 3. Then I can divide by 2, so I get cosine x equals negative square root of 3 over 2. Now, I would want to go over here, look at my table. So cosine is square root of 3 over 2 at 30 degrees. The issue here is this negative. So cosine is negative in what quadrants? So I want to ask you that. I want you to think about it. So cosine is negative in quadrants 2 and 3. So what this means is that we're not going to be able to use 30 degrees as an actual answer. We're going to be using it as a reference. So we're saying, okay, I know that I need answers in quadrant 2 and quadrant 3. They need to have a reference of 30 degrees. This is 180. So to get my quadrant 2 answer, I would do 180 minus 30, which will give me 150. And then I need to think about coterminal, so I add 360k to that. And then my quadrant 3 answer, I would do 180 plus 30, so that'll give me 210. And then I always want to add in the 360k. In radians, this would have been 6 pi over 6, and then my references would have been pi over 6 instead. So I would have had 5 pi over 6 plus 2 pi k, and I would have had 7 pi over 6 plus 2 pi k. Those would have been the answers for radians. And just another thing to keep in mind with you, if you want to use the general formula, you would have had to do x equals cosine inverse of negative root 3 over 2, and that would have given you 150. And then if you do 2 pi minus 150, or 360 minus 150, you'll get the other angle of 210. The only reason I don't really like the general equations very much is that I find that it's too much to remember once we add in the fact that we're also going to do sine equations and tangent equations. I do personally think it's easier to just kind of think through it how we've done previously. But it is possible to maybe see in a question that you have to use the general formulas. So let me show you one like that. I actually have the homework pulled up, so let me go ahead and get that real quick. I picked out one that you have to use it, so I wanted to show you. This one says cosine x is equal to 0.1633. And so I don't, that's not on any of my charts. Like I don't just know what angle to plug in here. So this is one of these cases where we actually would use the general formula. We'd say, okay, x equals cosine inverse 0.1633. And I would need to get that from my calculator. Now be careful. In this homework problem, it says to answer in degrees, so I'm going to make sure when I type this in, my calculator is in degrees. So I'm going to type in cosine inverse 0.1633, and I get 80.6 degrees. But be careful, this is technically plus 360k. And then for my second answer, I would do 360 minus 80.6, and then I still need to add in the 360k. So let me go ahead and get that. So it'd be 279.4. I'm just doing one decimal place, plus 360k. So my answers for this one are 80.6 and 279.4. Now it should make sense to you that since this was positive, we ended up with something in quadrant 1 and something in quadrant 4. So you can still kind of think through it a little bit, but it is possible to need the general formula. Not really on test 2, because I try to make test 2 possible to do with no calculator. But when we get to chapter 5 a little bit, there will be some cases where we have to utilize the inverse functions a little bit more, like with the calculator and stuff. But just a reminder, if you happen to, while you're doing the homework, you find that you need a calculator for certain problems, like for instance, this one I just did, you would need a calculator. That is not something you should expect to see on the test. The test should be able to be done with no calculator. That's usually how I structure the class. So just something to keep in mind while you're studying. I'm going to go ahead and bring my table down with us while I do some more equations. I think we've done a good bit of cosine, so let me go ahead and maybe work with sine a little bit. So example 2, I'll just say solve for all values of x. And the variable can be anything. Sometimes they use like Greek letters or something like that. And so we'll do a few of these. So let's start off with, we'll do sine x equals 1. We'll do sine x equals 0. And we'll do some more, but I never want to run out of space. So now for these, because I see 0 and 1, I am going to need like my whole unit circle and stuff. So let me go ahead and draw that. Okay. So sine x equals 1. We want to find what angle does sine equal 1. So it doesn't happen anywhere on my table, so that tells me, okay, I probably need to look at this chart. Remember that sine is like the y of the coordinate. So that's only happening in one spot. Oh, I did not mean to have the eraser on. Up here at 90 degrees. So that means that x equals 90 degrees. And we'll just say plus 360k, just like we did with cosine. So in radians, this would be pi over 2 plus 2 pi k. Next one, sine x equals 0. So this one, I'm looking for where sine equals 0. Doesn't happen anywhere on like the little table, but it does happen in two places here. So this one is very similar to like cosine, where cosine happens to equal 0 in two spots that happen to be right across from each other, so 180 apart. We're actually seeing the same thing here. So for this one, you can write it out. I will not take off points for this. If you write it out with like the separate answers. However, you can condense it a little bit and just say 0 plus 180k, which actually simplifies to just saying 180k. In radians, you would just say pi k. And so again, just like when cosine equals 0, we kind of have that exception where we use 180 instead of 360. Sine has the same exception. Let's do some more. Let's do one that might trip you up a little bit. Sine x equals 1 over square root of 2. So 1 over square root 2. This one, we need to be careful. 1 over square root 2, sometimes I've put something similar to this on the test and people almost treat it as the same as 1 over 2, but that would be incorrect. 1 over square root 2 is just the unrationalized version of root 2 over 2. So this can also be written as sine x equals root 2 over 2. So be careful, sometimes it'll be in like a weird form or something. So I'm looking over at my table, I'm looking at sine root 2 over 2, that happens at 45 degrees. So I know that 45 is my reference, so I'm going to write that here. My reference is 45. But I need to figure out what quadrants I'm supposed to be in. So this is positive, so sine is positive in quadrant 1. And then also, you think about it, where else is sine positive? Quadrant 2. So that means that for my answer for this one, I'm looking for the quadrant 1 answer and the quadrant 2 answer both which have a reference of 45 degrees. In quadrant 1, it'll just be 45, and then I add 360K. Quadrant 2, I would do 180 minus 45, which would get me to 135. In radians, this would be pi over 4 plus 2 pi k, and then this one would be 3 pi over 4 plus 2 pi k. And so then, like, let's say it had been a negative square root 2 over 2. The only thing that would have changed is my quadrants, because I would have had to think, okay, where is sine negative? Okay, sine is negative in quadrant 3 and quadrant 4. So my answers would have been quadrant 3 and quadrant 4, reference still a 45. Now, just like with cosine, sine does have like a general solution. So the general solution for y equals sine x is x equals sine inverse y. And then you got to remember the 2 pi k. And then the other one, just like what we did just now, right? So we got our first answer in quadrant 1. That's what this would give if it's positive. It would give quadrant 4 if it's negative. And then to get the other one, we did 180 minus that answer. So this one is pi minus that answer plus 2 pi k. So again, you're welcome to use the general solution. I don't really use them. Feels like too much to remember to me. Okay. So we will probably do some more sine ones and stuff, but I'm going to go ahead and jump to some tangent ones. So example 3, we'll do some tangent. So I'll just say solve for all values of x. And we'll do tangent x equals 0. And then b, we'll do tangent x equals 1 over square root of 3. Let's make it negative 2. So again, I'm going to bring down my table and everything just so that I can have it as like reference for kind of explaining where I'm getting my answers and stuff from. So let me grab that table and everything, and I'm going to go ahead and just pull it down. There we go. Now I don't have tangent currently written on here. So if I want to, I can just go ahead and add it in to the table. So remember it's sine over cosine. So here it'd be 1 over root 3. Root 2 over 2 would just be 1. And then root 3 over 1 would be root 3. For on like the unit circle version, remember that tangent is sine over cosine. So here it would be 0 over 1. So it would be 0. Up here, it would be 1 over 0, so it's undefined there. Here it'd be 0 over negative 1, so 0, and then here it would also be undefined. So I just went ahead and wrote in the tangent so that I could use it. So tangent equaling 0. Let's think about where that happens. That happens here and here. And I got it from doing the y over the x, which is the definition of tangent, or sine over cosine. So it happens at 0 degrees. It also happens at 180 degrees. So our instinct may be to say plus 360k. Tangent is a little different because tangent's period, if you think back to chapter 2, sine and cosine both have a period of 2 pi. Tangent has a period of pi, which means tangent will always just be adding 180. You actually never have to add 360 when it comes to tangent. So again, with tangent, you actually don't add 360. You would just do 180. Now, if you did do 360, that is not something that I would take off points for, but it is something to keep in mind, definitely for like as you're doing your homework and stuff like that. And so let me show you part B as well. So tangent equaling negative 1 over root 3. Well, if I come over here to my table, tangent 1 over root 3, that happens at 30 degrees. So I know that my reference is 30. However, this is negative. So I need to think about what quadrants is tangent going to be negative. So of course, I'll let you guys think for a second. Thinking of the all students take courses. So all are positive. T is tangent is positive. So it must be negative in 2 and 4. So tangent is negative in quadrants 2 and quadrants 4. So that means that I'm looking for angles in 2 and 4 that have references of 30. So for my first one, 180 minus 30 would be 150. And then technically my second one, if I wrote it out, would be 330. However, keep in mind, tangent's period is pi. If you add 180 to 150, you get 330. So you don't really need to separate them as answers. We can just say x equals 150 plus 330 degrees, oh sorry, not 330, plus 180 degrees k. And that would be our answer. Now, if you wrote it like this, I will give you full credit for that, but that is not what your homework is going to expect from you. Your homework is going to want the boxed in answer. And it's just because it's more condensed, right? So if you add 180 to 150, you get 330. So it's like, why would I write it twice when I can just write it once? And so tangent will always be that way. In radians, this would have been, let's see, denominator of 6. So this would be pi over 6. So this would be 6 pi over 6 because it's pi. And so that would be 5 pi over 6 plus pi k. But I just want to stress to you, like, if you did write it separately and you use 360, it's not incorrect. It's just not the best answer, but it's technically fine. Let's talk about the general solution. So for tangent, you would do x equals tangent inverse of y. And this one you would just do pi k. and then to get the other answer if you want it. But it's weird to me that they even write it in here because you don't need it. Like you don't have to type it in, even on the homework. You would do pi plus tangent inverse of y plus pi k. So that's if you want both answers. It's weird to me that they write both like this because you don't need to write both. So I'm just going to put that as a note here. You don't need both. All you'll need actually is this one. Now it is also possible that maybe you could be asked to only find angles within a certain interval. So I want to show you some like that. So we're on example 4. This one I'm just going to say solve for x values where x is between 0 and 360. So for this one, let's do a few. This one I'll kind of switch up sine, cosine, tangent, whatever. So we'll do let's do a sine one. Sine x equals -1. Let's do another one. Let's do another tangent just to, let me make it more of like something you have to solve actually. So let's say if I do square root 3 tangent x minus square root 3 equals 0. And maybe we'll do more. I don't know. We'll kind of see how. It'd be nice if we were in person because then I would, I kind of like to watch people's expressions and kind of gauge how they're feeling about everything and stuff like that. But for y'all, I obviously can't do that. So I just kind of have to go with it. So let me go ahead and bring down my table and stuff. And that's just what I'm always using. So that's always good to keep in mind of like, where am I getting these answers from? You know? So let's see. Sine x equals -1. Sine is the like y coordinate. It doesn't happen anywhere on like the table, so it must be somewhere on this. So it happens right here. So this answer is just going to be 270 degrees. And that's it. Now, if it had said for all values of x, it would have been 270 plus 360. But this one, we only want values between 0 and 360. So like we only want values between those. We don't want to go any bigger than that. So that's why we don't have to add the whole k thing. So be careful there. In radians, that would be 3 pi over 2. And that's it. Then for part B, let's go ahead and solve this one first. So I can add root 3 over. So I get root 3 tangent x equals root 3. Then I divide by root 3. So So that's going to give me root 3 over root 3, which be careful. Anything over itself is just 1. So I use the root 3s almost to throw you off to think like, oh, maybe it's 30 or 60. But actually, when you simplify it, it's just 1. So I come over to my table. Tangent is 145 degrees. But I need to be careful here because tangent is positive. So I got to think about where tangent is positive. Quadrant 1 and quadrant 3. Reference of 45. So my answers are going to be x equals 45 degrees. And in quadrant 3, it would be 225. If I do 180 plus 45, that's how I'm getting that. So these would be my answers. Be careful. I had to, like, usually for tangent, if it's the all values of x, you don't actually have to write both of them, but it's because you're going to say like plus 180k. In this case, we're literally just looking for the angles that are in that interval. So that's why we have to find each one almost kind of like individually and write them. In radians, this would be pi over 4 and 5 pi over 4. And so again, it's the fact that they're asking for x values in a certain interval is why we don't have to add like the plus 180k or plus 360k, whatever it is. Now, I'd also like to do maybe some inverse functions. Not inverse, sorry, I said the wrong thing. Reciprocal. I want to do some reciprocal functions just to show you like what those would look like. So let's do part C. I'm going to do secant. So let's do secant x equals let's do negative 2 over root 3. That's fine. This one, I don't want you to overthink it. Think about what secant is the reciprocal of. So secant is the reciprocal of which trig function? And so that would be cosine. And so secant is just cosine flipped. So if I'm seeing secant equal to something, I can just make it cosine and then just flip the other side. So don't overthink if you run into like a reciprocal function. Just go ahead and change it to the reciprocal and flip the other side, and then you're dealing with either sine, cosine, or tangent. So for this one, cosine square root 3 over 2, I look at my table, that happens at 30 degrees. So I know that my reference is 30 degrees. It's negative. So cosine is negative in quadrants 2 and 3. Reference of 30. So here I'm going to get 150 and 210. And that's it. And now again, right, it's because the directions said only for the interval from 0 to 360. So if they had said for all values, I would want to be like adding in the 360k, but they didn't say they wanted that, so I don't have to give it. So just be careful about what the directions say and, you know, what are they asking for and that kind of stuff. This answer in radians would be 5 pi over 6 and 7 pi over 6. And so that's really it. Some things I would just tell you to watch out for. Watch out for if they're asking for all values or if they just want them between a certain interval. Make sure that if it's something, like part B, sometimes you might have to kind of manipulate the equation. You are good once you have it equal to like a trig equation equal to just a number. That's kind of what you're looking to get. Watch out for quadrants, whether it's positive or negative, and reference angles, of course. So that's really it for this section. 4.3 and 4.4 are more equations, just kind of doing more stuff with them. And so you'll see some more of this in those next few sections. So I will see y'all in our next video. Bye-bye. Hope you're having a good day.